For two strings S and T, we say that T divides S if S can be made up of T plus T plus T plus T, etc. In other words, you can just concatenate T together some number of times to make S. So it's asking us that given two strings str1 and str2, return the largest string X such that X divides both str1 and str2. In other words, it's asking us to come up with the greatest common divisor of these two strings, given their definition of a greatest common divisor. So let's take a look at two examples. So let's take a look at these two examples. In the first example, you can see that ABC can actually just be repeated twice to make the top string. So you can repeat ABC once to make the bottom string ABC, and you can repeat it twice to make the top string ABC, ABC. So therefore, you would return ABC because that's the greatest common divisor of both of these strings. In the second example, you might be tempted to just say AB, AB because you can see like, oh, well, they both go together, right? However, you can see that you can't concatenate AB, AB together to get the top string because you would have some extra letters. However, you can take the string AB and concatenate it twice to make the bottom string, and you can concatenate it 3 times to make the top string. Therefore, you would return just AB in this example. So this is an unusual problem where the brute force solution is probably the one that you're going to be expected to give in an interview. After all, this is an easy problem. What we can actually just do is try every substring of the smaller string and see if we can just repeat it to make the longer string. So in this case, we could start by trying just A, and we could, concatenate it a bunch of times and see, okay, no, we can't make AB, AB, AB with this. So then we would go back and we would try the second 2 letters. So we could concatenate AB together, and then we could concatenate it again, and we can see, okay, yeah, we can make the top string. So currently our GCD is just going to be AB. So then we could go back and we could try, okay, so let's try ABA, and we concatenate it together and see, okay, that does not make ABA, BAB. So that wouldn't work. And then, of course, as we saw in the above example, if you take all 4 letters, you can't make it. So in this example, you would just return AB because that's the longest version of the smaller string that could make the entire longer string. So what would be the runtime of this? Let's say the length of the string is n. Well, you have to try every possible length of the smaller string, so that's n, and then you would have to concatenate it all together some number of times in order to make the top string. So that's going to be n again. So we would call this solution n squared. Now, technically, if we called the length of the longer string m and the length of the smaller string n, it's actually just going to be O of the minimum of m and n, whichever is the smaller string, because you're only checking every possible letter on the smaller string, and then it's going to be times n because you have to do it for all of the top string. So this is more technically the correct runtime, but you could probably get away with just saying it's n squared. Now, like I said before, if you gave this answer in an interview, they'd probably pass you, but there actually is a better solution. It's just that you really can't just derive it on your own. You kind of have to know the trick in order to come up with the trick. Okay, so for the fancy solution, we have to start with one simple observation. If, in fact, there is some smaller string within both of these strings that is just repeated over and over in order to make both of them, then it must be the case that just concatenating them together like this is the same regardless of direction. Now, why is that? Well, if both strings can just be described, in this case by AB, and we know that we're repeating it some number of times for the first string, and then some number of times for the second string, then it doesn't matter what order we repeat them in, right? If we decide to, say, do AB, in fact, if we repeat them, in not even in order, but just but mix up the strings like this, then this is still the exact same as taking the first one and then concatenating these together. It's just the letters AB repeated 1, 2, 3, 4, 5, 6 times. So once we've proven that these strings can be made up in this method, then we can define the string's length by some number k times some other number. For the first string, we'll call it n, and for the second string, we'll call it m. So in this case, k is 2 because k is the size of that substring. So they'll look like this. This one is 2 times 2. and this one is 2 times 4. But here's the thing. You can also describe this number as 4 times 1, and you can describe this number as 4 times 2. So without changing anything, we've changed k to 4. In other words, even though before we said it was AB, since in fact we can make it AB, AB, we can actually, through this very quick math, prove that you can actually make up both strings with a string of length 4, AB, AB. So how do we know which 4 characters make it? Well, it's just the first 4 characters of either string, because if both strings we know are made up of AB, AB some number of times, then it's just the first 4 letters. So if we go back and look at this example, we can still see that the first string is KN, where K equals what? K equals 2 times 2. And this one, it's KM, where K equals what? K is still 2. Sorry. K is still 2, but now it's times 3. And now you can't do that other method. Why? Because the greatest common divisor is now just 2. Therefore, for this example, you can just return the first 2 letters of either string. Now, again, this is a really fancy math solution that you pretty much can't figure out on your own if you don't already know the solution. So in an interview setting, I would definitely start by giving the first solution. Otherwise, the interviewer is kind of going to know you've seen this video before. But regardless, let's go ahead and code up this solution. So let's do that first solution. First, we're going to need the length of both strings. So let's just get that. So int len1 equals str1.size, and int len2 equals str2.size. Okay, so then what we need to do is we need to loop through the smaller string and try every version of that until we have the GCD. So do I equals the full size of the smaller string. So that's just going to be the minimum of len1 and len2. And while there's at least 1 character left, keep going backwards until we find a solution, basically. So what we're going to want to do is have some function to check if the solution is valid. And if it is, so we'll do if valid. What we can just do is return, and we don't really need to know which string it is because it's the same substring from the beginning all the way to whatever length we found, because we're going backwards from the smaller string. And if we don't find a solution in that fashion, we can just return blank. Okay. So in that case, we need to create our valid function. So what the valid function is going to do is tell us if we break each string into a substring of length k, can it fulfill the solution? So we'd take in str1 and str2 and that int k. So we're going to need we'll get the lengths of str1 and the length of str2. And then we can instantly see if they're not valid, if in fact the lengths of the string don't divide by k in the first place. So if that doesn't equal 0, or if len2 mod k does not equal 0, then you can just instantly return false. Otherwise, we need to get what is that substring that we're checking. Well, we know it's the substring of length k within either of the strings. It doesn't matter which one we actually grab. So let's just grab it from the first one. Okay, now comes the annoying part where we actually have to check each of those strings. So let's start with the first string. So we have to do for int I equals 0, and while I is less than str1.size, I needs to be plus equal the size of that number k, of that substring length. And what we have to check is str1.substring from position I to position I plus k, does that equal the base? If it doesn't equal that, then we can return false. And in order for string 1 to be made up of that base, it has to be true all the way through. And then it's the same thing with the second string, right? str2.size, str2, and so on. So if we're able to make it through all of this, then that means we can return true. So then let's go ahead and fill in that call to valid down here, and let's test to see if that worked. And it did. Okay, so that's the slower solution. So now let's do that other solution that we found. So remember, for this solution, the first thing we need to check is, can you concatenate them together in both directions and get the same string? So let's just try that. If str1 plus str2, if these are not the same strings, str2 plus str1, then you can just instantly return an empty string. However, if you are able to pass that condition, then it must be the case that there is some substring. And how do we find that? Well, we just find the greatest common denominator of both the string lengths. So GCD len equals the GCD between str1.size and str2.size. And then all you need to do is return that substring. So GCD len, and there you go, beats 100% of submissions. But remember, you probably won't be expected to come up with this on your own.